Wow, you guys are a quiet bunch. Somebody say something funny in Polish. What he said. I guess it was funny, thank you. All right, this particular presentation, I'm going to talk to you about several different REST frameworks. As a matter of fact, I think in the abstract that I submitted to DevOps Poland, I think I said we would cover 3. I lied. I added one last week, so we will actually talk about 4 of them. We'll talk a little bit about REST, concepts, blah, 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 before we get into some of the practical stuff. That's me. If anybody cares, you can look it over in the slides later. What are we doing in here? We're talking about REST. And by the way, I don't particularly like the debate around REST. I don't particularly like the debate around what is RESTful and what is not. I think it's kind of pointless and stupid. Roy Fielding certainly had an idea when he coined the term representational state transfer. I think it is useful to look at that particular architecture. I think it's useful to understand what REST is and what REST isn't. So on that score, I'm actually very happy to engage in a debate as to whether something does follow Fielding's notion of representational state transfer or not. The part that I think is really stupid is the part where we say that if you're not RESTful, you're not useful. And that's a lot of the implicit discussion that goes on. You must be REST, or you must do this, or you must not. Hey, you know what? At the end of the day, if you find it useful, if the people that you're building this endpoint for find it useful, then it's useful. And I don't really want to get into religious debates as to what, whether a thing is or isn't. I'm interested in having the debate from an ontological perspective. What defines a REST-style architecture so that we can use it as a descriptive term? But the actual religious debate, I got better things to do with my time, and quite frankly, so do you. So we're going to talk a little bit about what Fielding had in mind, and specifically, we're going to talk about what I will refer to as web APIs, the fact that you are using HTTP and JSON as a mechanism by which you can communicate data. All right, we're not talking about doing a traditional MVC-style presentation layer. We are talking very specifically about the idea of using HTTP as a middleware transport to schlep data back and forth between the client and the server and or the data storage area where it resides. Towards that end, there are several different toolkits that have emerged in the last several years that are designed towards tackling this particular problem, and in some cases, only this particular problem. And because there's been so much emphasis in recent years about web APIs and JSON and whatnot, particularly thanks to some front-end technologies like Angular, as well as all of the mobile applications out there, iOS and Android, of course, being the 2 big ones. So we're going to look at 4 of these different frameworks. And you'll notice I call it Spark Java. This is not Apache Spark. This is another framework that calls itself Spark. We'll talk about that guy in a little bit. But if you came in here thinking that I'm going to talk about big data, now's a good time to duck out the back while nobody's looking. Okay? I'm not going to be going over big data in any stretch or process. The theory around some of this RESTful stuff, right? Using elements of client-server, pipe and filter, and distributed object paradigms. This optimizes the network transfer of representations of a resource. This is straight out of Fielding's thesis. If you have not read Roy Fielding's thesis, this is something you should do at some point in the next month or so, okay? Not because it's going away, but because Fielding's thesis is the closest we have to any sort of canonical, holy book around what exactly defines representational state transfer. If you want to build something and you want to understand the RESTful architecture, Chapter 5 in particular will be useful, but the previous 4 chapters sort of lead up to what they came to with the architecture of the World Wide Web. It takes the position, the RESTful state transfer architecture takes the position that the web, as it currently exists, in other words, the browser-based World Wide Web that we know and love, it works pretty well. it works pretty well. And so therefore, if we already have an architecture that works, let's just stick with that. Now, quite frankly, I'm going to disagree with this somewhat slightly from the standpoint that it works particularly well for the problem for which it was defined. In other words, I want to be able to engage in the consumption of hypertext documents across a distributed medium that has no controlling hierarchy, etc. And again, Fielding lays all of this out in his thesis, which is why it's so critical to read, because he not only describes the solution, but he describes the context, the constraints that they used to build this system. Not everything needs to fall into those constraints. Particularly one area where REST doesn't work super well, or you have to make several concessions to reality, is when in fact you cannot send all of the data as part of the hypertext document. When in fact you have to hold some data on the server either because it's sensitive or because it's not appropriate or what have you. And again, Fielding's thesis goes into that in some detail. The idea behind the model, though, is that we treat everything as a resource, and then we use the basic verbs of HTTP to interact with those resources. Now, one of the reasons why we've liked REST so much is because resources seem to fall in very, very closely with objects. So if you have an employee object in your domain model, it seems very natural to say I have an employee resource that can be accessed via URLs using the various 4 CRUD verbs of HTTP. And thus we get into the notion of modeling things as resource, right? As resource says, because presumably we typically have more than one of them. In many respects, what we're doing is we are creating a system that models these resources, these nouns, these objects, as something that can be directly accessible, right? And we make the verbs publicly available, and we have a very constrained set of verbs and a wide set of resources. In a lot of ways, this feels like a flip from traditional object-oriented programming, where we will typically define a number of objects, but we will define a number of operations on each of those objects that are more than just simple CRUD. And this is where REST and object orientation have a tendency to start to butt heads with one another. If I have a person object over here, and I have a person object over here, and I have a requirement that says 2 persons should get married, right? You know, dearly beloved, we are gathered here in the presence of God in this conference to join this man and this woman, or this man and this man, or this woman and this woman, or this man and this dog, whatever, right? To join them in holy matrimony. Well, from an object-oriented perspective, we struggle with this a little bit, right? So if I have an instance method, person A dot marry person B, right? Does that mean that B also is married to A, or is this just kind of a one-way thing, right? There are several people I know who wish marriage was one way, including my wife. So we frequently think about that and say, okay, well, maybe it's better off as a static method, right? Person.marry, parens A, comma B. And that works for Java. But when we start thinking about this from a RESTful perspective, how do we hang a static method out there somewhere? We start trying to think about different resources. Maybe the resource is a marriage, right? So we'll do a put to the marriage resource consisting of these 2 persons, which would be similar to having an object called marriage, and we would have to new it up. And in some cases, we start running into these kinds of scenarios where they don't exactly line up one-to-one. As a matter of fact, one of the early RESTful implementations, Couchdb, Couch, by the way, if you're not familiar, its database protocol is HTTP. So everything you do in Couch is intrinsically HTTP. It's intrinsically supposed to be RESTful. And the Couchdb implementers made it very clear. We tried to follow REST as far as we could, and then we just made it work. So trying to build a purely RESTful model is actually very difficult, given some of the systems that we're trying to do. Excuse me. Now, there is something to be said for this model, right? It is very well established. It is very well documented. I mean, you just go out there on the web and start looking at some of the history of how the web was built, and there's tons of people who've written articles and whatnot. Tim Berners-Lee Very, very happy to discuss some of the decisions they made and why they made them. And if you can tap into the infrastructure of the web, there's nothing new you have to build. One of the problems that we ran into during the earlier web services phase, 2000, when we were talking SOAP and WSDL and all of those things, we were running into some serious issues because trying to tunnel everything through SOAP endpoints, one SOAP endpoint on port 80, meant that a lot of the caching infrastructure didn't work, and when we tried to reverse it, some of the reverse proxies got in the way, and it was a mess. People were actually talking about purchasing hardware SOAP routers just to help deal with some of the problem. And anytime I'm suggesting, anytime that I am trying to project an architecture onto your company that says, by the way, you have to give IBM like millions of dollars for hardware, something's busted. All right, that's just a problem. The RESTful infrastructure is already there. We're already using it. It already works very, very well. We know it's payload agnostic because you can ship anything over HTTP. As a matter of fact, we do. Right? We ship video, we ship audio, we ship streaming video, streaming audio, right? As a matter of fact, if you really want to test the efficacy of your distributed architecture, the basic question is, how well could I do porn over it? If I cannot do porn over your particular distributed architecture, it's not payload agnostic. Because as strange as it seems, the pornography industry has actually been pushing the boundaries of the web long before anybody else. As, not that I know firsthand, of course, but it's a well-defined solution. It's obviously extensible, and quite possibly one of the best things about it is it is clearly platform neutral and technology agnostic. That is important because when I started this conversation, we were talking about building endpoints not only for browsers like AngularJS, but also for mobile apps like iOS and Android. Being able to encompass all of the different client platforms is a really serious goal that we need to hit. It provides anarchic scalability. This is one of the terms that Fielding uses in his thesis, and basically it means that we can scale without having to register with some central authority. If your server currently sitting on one machine is not enough to handle the load, you can just start adding machines, putting in a web farm, etc. There's nobody you have to register these things with. You may have to set up a DNS sprayer so that the requests come into a known IP address and then get sprayed out, etc. But the presence of the cloud, the fact that I can literally email or phone or just go online and fill out a form, or if you use Heroku, I just move a slider and all of a sudden I have more machines. I mean, that is almost the definition of anarchy. There is absolutely nothing stopping me or anybody else from growing or shrinking depending upon demand. It allows for independent deployment, and in many respects, it returns us to simplicity because it's HTTP, it's URLs, and then it's whatever your particular data format is. HTML, of course, for doing presentations, XML and JSON for doing data. The drawback is it relies a great deal on the underlying technology. And in some cases, the technology is useful but not sufficient. Probably the most obvious example here is security. This is one of the reasons why we keep seeing various efforts underway. The current one is OAuth and OpenID, but there were several efforts before that, WS Security, and there were a couple of efforts before that to try to create a security model that will federate well, but also allow us to be as coarse-grained or as fine-grained as we need it to be. And OAuth, it's great for being able to do identification, for being able to do authentication. I know who you are based on the fact that you have authenticated through Facebook with me. But then from there, how do I know what you're able to do? Every system has to build that for themselves. And we're probably going to leverage a few models, a few frameworks, etc., but you're still something that you're going to have to build for yourself. REST says absolutely nothing about it. It requires a loosely bound API. Get, post, put, delete, these are very, very vague terms. And in some respects, some of the specific parameters you're going to have to discover either the hard way by just plugging random values at it until something works, or you're going to read the documentation. Because developers are really good at writing documentation, and the documentation is always correct, right? Right? For my project it is, right? Go like this. Yes, because I would never ship something with crappy documentation, would I? No, 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 no. And what we're seeing, one of the advantages of the web services world is the fact that we had tools to describe the endpoints in a descriptive manner such that a machine could consume them. We called that WSDL, and the idea of WSDL was good. The execution of it was flawed and terrible and horrid and clearly designed by committee, but the idea of it was good because now we're starting to see people reinvent that same kind of infrastructure. We're now starting to see Swagger and RAML and some of these other languages being invented specifically to describe a RESTful endpoint so that machines can consume them and do various and interesting things to them, like automatically generate unit tests or just start plugging random values at your endpoint in order to get a particular value. So REST is good, don't get me wrong. I like the representational state transfer, the architectural model. It hangs together very well for doing distributed hypermedia documents across the web. It also has its flaws, and so one of the things we want to do is we want to look at that very, very clearly and with eyes wide open. Now, is there anyone in this room who does not know what HTTP is? Please raise your hand so that we may mock you. Nobody wants to be mocked? Oh, come on, I was so hoping to mock somebody. Oh, fine. Hypertext. You got the second T. Hypertext Transfer Protocol, yep. It is basically the backbone of the web. If you read the HTTP specification, which, again, if you haven't read the HTTP spec, you need to do so. There are a lot of interesting little tidbits hiding out in there, particularly because HTTP 2.0 just recently shipped. Now, whether HTTP 2 will actually turn into something remains to be seen, but the HTTP 2 spec has officially shipped. It's been blessed by the powers that be. HTTP 1.1 is still obviously the most popular protocol on the planet because everybody speaks it. And quite honestly, well, HTTP actually may be number 2, where SMTP, the protocol for email, is probably number 1. Because, you know, if you had to live without one or the other, web browsing or email, which would you pick? If I had to give, actually, a lot of developers would probably give up email because then people would stop bugging them, right? No, user, it's supposed to work that way. Never mind, I'm not going to respond to your email. We've seen a couple different versions of it. Originally, Tim Berners-Lee created version 0.9 in 91. From 91 to 95, we saw 1.0 making its way across the web. This was the nascent era of the web. In 95, it shipped 1.1, and by this point, the web was starting to make its way into the consumer space. And over the next 5 years, this was the rise of the internet boom, et cetera, to the point where now it's ridiculously popular. And the interesting thing is that 1.1 has been our official standard ever since 1995. This protocol has stood in place for 20 years. There have been several attempts to revise it ever since to fix some of the holes with it, but it's remained pretty solid and straightforward. And quite frankly, one of the beautiful things about that is that it means that it will be here for years to come. We will never fully transition out of 1.1 because there will always be some legacy servers that nobody wants to touch that are still running 1.1. And HTTP has some built-in backwards compatibility, versioning, negotiation, et cetera. So that's good. We can continue to live with that. It is the de facto standard protocol of the net as a whole. As a matter of fact, one of the problems that I have is that people keep trying to do stuff over HTTP that they shouldn't. We keep trying to do file transfer, and we keep trying to do, in some cases, email as a protocol over HTTP, when we actually have some better protocols to do some of that stuff. People are now trying to do bidirectional streaming communication over HTTP, web sockets. You know, we have a name for that. It's called TCP/IP. We could just go back to TCP/IP, but that's not sexy, and it doesn't have the word web in it anywhere. So no, that's clearly no good. We can't use that. So we have to reinvent the wheel in some cases. It's obviously the protocol of what Fielding originally designed as part of the RESTful scenario. Again, I strongly suggest you read Fielding's dissertation. There is another document entitled The Architecture of the World Wide Web. It's another W3C document that talks a little bit about kind of what they had in mind when they were thinking about the web, when they were starting to build a lot of these protocols and these standards. The document, I believe, is dated 2000. It's either 2000 or 2001, and I believe it's written by Norman Walsh. It's not written by Fielding, but one of the guys that he worked with at the W3C. And the interesting part about it is there are a couple of statements in there that you may agree or disagree around, for example, the construction of URLs, right? Should URLs be, in fact, self-descriptive, or should they be somehow abstracted away? You get different opinions depending on who you talk to, and there's pros and cons to both approaches. But the document itself is a worthy read just to go through that exercise and decide whether or not you agree with what he says or not. Again, in many cases, REST was designed the way it was to build the web the way that it is. If you are not currently trying to build the web within your company, if you're not trying to replace the web, the RESTful style may or may not work, and that's okay either way, all right? Sometimes I think we get too caught up in the I have to do it the right way, whatever that really means. Okay. Let's talk about some frameworks here, because Java guys love frameworks, right? Java girls, too. They love frameworks just as much, right? So what I want to do is I just want to give you a very brief introduction to these 4 different frameworks, all right? And they range in size and complexity and so forth. And I'm doing this deliberately, not because I think one is any better than the other. There are times when a very simple solution will be best. There are times when something more complex will be best. I'm just making you aware of 4 different tools and then saying, experiment with them, figure out which ones work for you, and then, implement, make it work, ship it. It'll be due next week, okay? You guys ready to do a sprint next week, right? Yes? You caught that in my requirements, right? God, would you guys eat lunch and you're all falling asleep in here because it's dark or something? Come on, wake up. Wake up. All right, here we go. Vodka for everybody. You didn't even react to that? Vodka for everybody? And you're like, oh, no, I don't think so. All right, let's talk about Spark. Again, Spark is not Apache Spark. This is what's called the Spark Java framework. It's a very minimalist framework, all right? In some respects, it's not even fair to call it a framework. It's more like it's just a library. It's very heavily influenced by Ruby's Sinatra framework. And the idea here really is to get us to the absolute bare bones of here comes an HTTP request and I can respond to it, the end. So a lot of the traditional tooling and support and so forth that you may be expecting from a web framework like Grails or Play are not here. Because realistically speaking, all I want to do is respond to an HTTP request, the end. Okay? Now, you could go ahead, if you really were fond of Sinatra, you could go ahead and run Sinatra on top of JRuby on top of the JVM. JRuby has actually been able to run Ruby on Rails on the JVM for several years now. But the problem is you're still writing Ruby code, and if you prefer Java code, or if you just can't get the boss to buy off on the idea of using Ruby on top of the JVM, or you just prefer a statically compiled language over a dynamically typed one, whatever reason, you don't want to write Ruby, but you do want to use that style of programming, it makes a whole lot of sense. The other reason you might choose this is because you look at JavaEE with all of its various moving parts and say, blah, it's just too complicated, it's too much work, I don't want to have to plug into a JavaEE container, I just want to stand up a very small endpoint. This would make a lot of sense, particularly on constrained computing devices, right? People are starting to talk about all of the various wearable devices, right? The glasses and the wristwatches and I don't know, before too long, you're going to have Android underwear. I don't know, right? Measure your body temp, right? You're going to want to run web servers on all of these things because these will not always want to be the client. They may actually want to be the server so that your phone can ping the device. I don't want to have something that's really complicated and heavy when we're talking about a very constrained device. So in many cases, doing something smaller is better than doing something bigger. To get started with Spark Java, 2 ways to do it. You can either go to sparkjava.com and download the bits, Or you can just use Maven. Spark Java is in Maven Central. You just have to set the group ID correctly, like that, right? Again, the version may change between now and the time you get home, but it's been at 2.2 for a little while. So I think this code will compile. All right. Now, let's go ahead and create a very simple Spark application. All right, we're just going to create a very simple hello endpoint to just, say hello, because hello world is it's the first thing you have to do with every application. And any questions? I kind of feel like I should be talking and stretching this out somehow, but it really is that simple, okay? This is the advantage. This is the reason you use this, is because it is that simple. I have a main. I use the Spark class. Notice the static import up there at the top. I create a route here, and you can see that it's a very Node-style routing, or a Ruby on Rails style routing, where I define the URL endpoint over there on the left, whack hello, and then I have a Java 8 style callback there on the right. Spark is designed to work with Java 8. I have never tried to do it with Java 7. I suspect it won't compile. I suspect they have targeted 8 specifically for the Lambda functionality, and they're not looking back. And you notice we're getting the ubiquitous 2 parameters you would expect, request and response. And notice that it just yields the string hello world back. Spark will actually do a couple of conventions. If you yield back a string value, they will assume that is the content that you want to send back. So in terms of standing up a very simple, lightweight JSON server, it doesn't get a whole lot simpler than that. No, by the way, notice it's running main there. We're not running inside of a container. The web endpoints, the web server, the socket machinery that's opening up port 80 and listening, blah, 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 all of that is happening inside of that GET request. So that now I do a curl, I point to that URL, and I get back hello world. Okay? Doesn't get a whole lot more straightforward than that. Like I said, it takes its cue very strongly from the Ruby Sinatra framework, but of course, this is Java, not Ruby, so we need to make sure that we follow some Java-isms, and we need to make sure that we take advantage of what Java offers in terms of static compilation and whatnot, right? So, what we end up doing, first of all, is we end up defining routes. You saw already that we had a route, but it was made up predominantly of 3 different parts. The verb, which is expressed as that function, right? The get method, which is, again, static method off of the Spark class. The path, which is defined in the first part of that parameter, /hello. And then the callback, which is the method to execute when this request comes in, all right? Again, all of the standard HTTP verbs are present: get, post, put, delete, head, trace, options, and the more recent one, connect, which I keep forgetting about. The path is a straight up URL pattern, okay, and they will be applied in the order in which they are registered. And the callback is just a function. It's just a Java 8 Lambda that will be invoked when that request comes in. Paths can contain parameters. So if I do :name, that creates an implicit parameter called name. And so if I say hello / name, that now means that I'm expecting a parameter there, which I can access via the request object using the params method. If I also put a splat in there, that basically says anything that follows in the URL pattern should get bound into an array that the request object calls the splats array, because splat is apparently a technical term. Okay? The request object, you know what? It has pretty much everything you would expect an HTTP request object to have, right? Body, cookies, params, headers, host, IP, port, URL scheme, request, all of the same information that you would expect out of the HTTP servlet request object that you've been using for years, right? User agent is actually hard-coded to examine the user agent header and reveal that information, so you don't have to use that method. You could use headers to go look for it directly. Content type yields the type of the body, length its length, body the actual body, etc. Response, again, same basic story. If you want to set a different status code, 200 is implied, unless you throw an exception out of the callback, in which case they will assume it's a server error of 500. We can set headers, we can redirect to a new URL, set the content type, etc., etc. Right, whoops, too fast. One of the things that people will hotly debate when we start talking about building web API endpoints is whether or not you should support some notion of session, right? So that when you come request something off of me, right, I can keep track of who you are because I typically send back some kind of cookie value, keep sending that as a part of each subsequent request. If you talk to Roy Fielding, if you read his thesis, you will see no mention of cookies because cookies are in fact not RESTful. This is where we get that lovely acronym, HATE OAuth, Hypertext as the engine of application state. In other words, as far as REST is concerned, all of the state or around the interaction between you and I, all of it should be buried in that document so that there is nothing I have to keep track of here on the server. Now, obviously, that works if we're browsing static HTML pages or if you're cruising through CNN and watching the latest NBA Finals game or what have you. But when we start talking about wanting to build web applications, in other words, where I need to keep track that you have authenticated and who you are, et cetera, I need to keep some kind of server state, this becomes trickier. Many of these frameworks are opinionated as to whether or not you should or should not use sessions. Spark doesn't register a particular opinion. They say we have the ability to create a session just like we do with servlets, and it will be a session scope, as in I send back a token, I send back a cookie that gets registered in the browser, it will expire over time, etc. Whether or not you choose to use it, this is your own architectural choice. For the most part, if we're talking about building web API endpoints, I tend to prefer not to use sessions if I can possibly help it. And I will identify you based on your original HTTP 401, 403 authentication stuff. That's just baked into the HTTP protocol. And if I need anything more, I'll try to support it on the server based on who you are. Doesn't always work out that easily, and in some cases you have to get a little bit more sophisticated, particularly if you want to get to single sign-on and all that stuff. If you want to do OAuth, you got to manage that yourself, blah, blah, blah. Kind of up to you as to whether or not you want to support sessions. Spark also supports what are called filters. They're exactly the same as servlet filters. This is code that can execute before a request or after a request has finished, right, giving you that same style of interception sort of goodness that Spring gives you out of the box, but here you're doing it around URL endpoints as opposed to arbitrary methods. So the Spark framework, again, it's very straightforward. I mean, I could easily have created a bunch of sample code that we could walk through here, but quite frankly, it's really straightforward. And you'll notice that there's not a whole lot here that isn't HTTP related. We're not talking about doing any sort of view framework. We're not talking about doing any sort of persistence, nothing. Spark Java does HTTP. That's all it does, the end. So if you're looking for persistence frameworks, if you're looking for health checks and monitoring, if you're looking for something that will be able to tell you how many requests have been served today, you have to build that all yourself, or we move on to a future framework. The next one, Vertex. As a matter of fact, interesting bit of news. I was on Twitter earlier today, and I saw a message from the project maintainer of Vertex, Tim Fox, I think his name is. Vertex 3.0 shipped today, like just a couple of hours ago. Now, 3.x I have not included in these slides because it just shipped a couple of hours ago. All right, so yes, technically I am showing you out-of-date information. Sue me, okay? That would be the American thing to do. Vertex Dot Io. One of the interesting things about Vertex is the fact that it is out of the box designed to be a polyglot framework. So if you're sitting around in the office, and some of you like Java, and some of you like Scala, and some of you like Groovy, and some of you like Clojure, and none of you can agree on what language we should use for our next project, it's okay. It's okay. These guys have you covered. They have all of those languages and more involved as a part of the project. There are three basic things that they want you to think about when you talk about Vertex, specifically verticals, right? The idea that we're going to build these components. A vertical is a vertex particle, Right? So that's one of the things you get to do. When you create a new framework, you get to make up names. All right? So I'm going to create a new framework, and I'm going to have you building tentacles before too long. Verticals run within Vertex instances, and again, you use lots of different languages, including on the same project, if you so desire, to actually register the work. The other thing that they don't really trumpet real loudly to start, and it's kind of out of scope for what we're talking about, but Vertex also has what they call a distributed event bus, so that it allows for a little bit easier communication between client and server. They're actually going to manage a lot of that for you in a pub-sub style of communication. So I can actually have several different components all listening to the event bus, responding to various requests. Again, this is a little out of scope for what I want to talk about, but it's there and it's interesting. And it's definitely something that I think you should look into. The other thing that Vertex really tries very hard to do is to be very scalable. What they will do is they've actually sort of embodied the Node style of event handling, where they have a pool of threads that they will run, and then when they call out to your code is single-threaded, but you're running on a clock, meaning don't block what they call the event loop. Don't do any blocking work inside of your code. If you need to do blocking work, like you need to call out to a relational database to get some data, they would prefer you do that on a separate pool of threads that they call the worker pool. So in some respects, the Vertex guys seem to be embracing some of the multi-threaded approach that Node.js has taken for many years to greater or lesser degree. And if you need to do blocking work, they will have you do that on a worker thread and then communicate between these two using that event bus. It's a different way of approaching things. It's not bad, it's just different. To get started with Vertex, several different ways to do it. Again, you can download it off of their webpage. Or my personal favorite, those of you who are on Mac OS, if you have not discovered Homebrew, you are missing out. It is a fantastic tool for doing package level management. Brew install Vertex and you're done. It's just, it gets installed into user local, everything gets configured correctly, it's beautiful, I love it, doesn't require admin privileges. Oh, I'm in love with Homebrew, I can say it out loud, I admit it. You can also generate it out of Maven, or you can also generate an example project that uses Gradle, whatever floats your boat, either way it goes. Ultimately, what you need to have is the Vertex command line tool somewhere on your path. Either put it there manually if you do a manual installation, or let one of the package managers do it for you. Okay? Now, to create a Vertex vertical, in this case, let's use everybody's favorite language, JavaScript, because I understand Hadi in the opening keynote really trumpeted the benefits of JavaScript to all you guys, what a clean language it was and how well it worked, and none of you went to the opening keynote, did you? Anyway, JavaScript, hello world. Anybody here ever done any Node code? Doesn't that look exactly the same? In many respects, it is exactly the same. Part of the thing is Vertex is trying to, for several of these languages, they're trying to make sure that they follow the various ideas, metaphors, warts of that particular language. So here we do a require to get the Vertex component, and then we create an HTTP server, and we set up a request handler. Right? Now notice here, I'm not setting a particular URL path. I can do that just as easily by putting a /hello in front of the function. But you can see request.response.end, hello world, that will send it out. Notice I immediately take that returned object and start listening on port 8080 on localhost, because presumably that's what I want to do on this particular machine. And then to run it, Vertex run server.js, browse to it, you get hello world. Now again, like I said, Vertex is a polyglot platform, which means this is what it looks like in Ruby, and this is what it looks like in Cylon, because for whatever reason we needed to support Cylon, or Ceylon, or whatever the hell you pronounce that. This is what it looks like in Clojure, because, you know, if it's not in Clojure, then it just isn't cool. And this way I look smarter, because if you can actually figure that out, you must be just as smart as I am, right? And then this is Scala, because I like Scala. There's also support for Groovy and a couple other languages as well, right? Now again, one of the things about Vertex that's definitely different from some of the other frameworks is that Vertex will actually support more than just HTTP. So remember that earlier rant I was going on about how WebSockets are stupid because we already have TCP/IP, and one of the drawbacks, of course, is that trying to create a TCP/IP endpoint in Apache Tomcat is pretty much close to impossible. I mean, it's not impossible, but it's pretty close. You'd have to really understand the Tomcat plumbing and how would you get around the fact that it wants everything to be HTTP, blah, blah, blah. Vertex actually supports a whole bunch of different things, to the point where if you want to stand up a very straightforward TCP/IP socket endpoint, great. Instead of create HTTP server, it's create TCP server. And then give it a port number, and now you can respond to incoming and outgoing requests very, very easily. It's very Node-like in terms of how it approaches code, and that's either a good thing or a bad thing, depending upon how you feel about Node. If you're, in fact, trying to take some Node code and port it to run on top of the JVM, and if you think that's silly, it probably is, but I suspect that many businesses that have started building all of these Node.js minimum viable products are going to start looking for a more stable, manageable platform to run on before too long. And they're going to look at the JVM, and this is one way to take your Node.js code and bring it into the JVM, which has lots of goodness and happy feeling about it with respect to enterprise businesses. It's embeddable, the event bus, I mentioned that. It's very concurrent friendly, right? One of the nice things about Vertex is you don't have to worry about your code being reentrant, because Vertex guarantees that your vertical will only have one thread running through it at any given point in time, right? And that is nice because it makes it much easier to reason about your code when you don't have to think about concurrency scenarios. And I already mentioned the worker thread scenario. So Vertex is nice. It's a little bit more than what we see with Spark Java. It's also got some breadth to it in the sense that it can do more than just HTTP. But again, we're not seeing any sort of management and monitoring type tools. We're not seeing any sort of automatic serialization, deserialization tools. But we do see a breadth with respect to languages. And so in many respects, this can be an easy way for, if you start working with Vertex writing Java code, and then you want to start experimenting with, well, will this library and closure work better than what we're currently trying to do in Java? Or I want to start playing around with some Scala-isms, right? You can start to fold those in without having to completely convert to an entirely different server or framework. So there's some advantages there. The next one on the list is called DropWizard. DropWizard is interesting from the standpoint that, again, what they're trying to do is they're trying to build, it's almost like a Grails type effort. We're trying to build an ecosystem of components, libraries, etc. On the one hand, we want to make it such that you can interact with it directly. On the other hand, if you need to package this up and put this into an existing JavaEE environment, sure, we'll generate a WAR file for you, and you can drop this into Tomcat if you so like. But it also, you'll notice this third bullet, pulls together stable, mature libraries from the Java ecosystem into a simple, lightweight package. In other words, they went out, they surveyed the entire Java landscape, and they said, there are certain libraries that we think are really useful and really helpful, and so we're just going to package it all up as a single stack and give that to you. It's not going to be too heavyweight. We're not trying to reinvent JavaEE. We just want to focus on allowing you to do REST-style endpoints, and that's it. But we want to give you a lot of stuff so you don't have to put all that stuff in. So these guys are definitely to the right of Spark and Vertex in that they're giving you more non-HTTP related support. They've also got out-of-the-box support for sophisticated configuration, application metrics, logging, operational tools, et cetera, meaning we're trying to give you some decisions out of the box, architectural decisions, if you might say, so that you don't have to worry about wiring these things up yourself. They've got metrics, they've got logging, they've got configuration, et cetera, both of which the previous two you could do, but you'd have to do some wiring yourself. It's a full stack framework. It builds on top of JAX-RS in a number of ways. So if you're familiar with JAX-RS, you're going to feel somewhat at home when you start working with DropWizard code. It includes a bunch of libraries: Guava, JODATime, JDBI, Logback and Sliff4j, Hibernate Validator, Liquibase for doing database refactorings, etc. So you get the sense that yes, it's lightweight, but it's definitely heavier weight than what we saw before. It's also very, very resource focused. These guys are really taking the concept of REST and they're exposing it, they're projecting it through the framework very strongly. We'll see that in a little bit. Why would you use this? Well, again, you want to have a web API type focus, full stack. I don't want to have to mess with a lot of things. I want my framework, I want my tool of choice to have a bunch of things that I can grow into. All right? I don't want to have to make these decisions later. I want you to have made these decisions. I want you to have these things so I can just flip switches and all of a sudden I get application monitoring and health checks and so on and so forth. All right? The other thing that DropWizard will do is it also helps with some versioning by virtue of the fact that they have out of the box some configuration to build fat jars. In other words, I don't have to ship 27 different jars up onto the server. We'll take all those jars plus my code, mash them together into one jar, and put that up to the server, which in many cases becomes easier to version, date, etc., to make sure that we're always running the latest bits of the right code. To get started with DropWizard, again, you can download from dropwizard.github.io, or you can just reference it in Maven. Okay? So here, because the version numbers around DropWizard are a little bit more unstable, they suggest you create a property and then reference the property inside of Maven. I believe 0.9.0 just went to snapshot like a month ago. And some people are already starting to talk about 0.9.1 and or eventually reaching a 1.0. I'm not entirely sure what the discussion points are there. To get started with your code, the first thing that they want you to do is to create a configuration class. This is designed to allow you to provide configuration information. This class is pretty straightforward, right? I simply define some properties, right? Template in this case, to get and set what the default name that I want to greet somebody with is, right? And that will actually turn into a YAML file here, right? So you can see up at the top where I've got it begin and end. This is the structure, right? Hello %s, that's the format, that's the template I want to use. If you pass in a value, then I will say hello, whatever that value is, otherwise I'll default to stranger. There's nothing magical about template or default name here. Those will match some of the settings that will go into my configuration class is all that's going on. The YAML file, this is something that DropWizard has chosen to use as a configuration file format. And if you don't like it, well, tough. That's the decision they made. This is the joy of working with opinionated frameworks. Now, after you've created your configuration, and it feels a little backwards to start with your configuration before you do your application class, but the application actually makes use of the configuration class as part of its declaration. This is the entry point of the application itself. And basically, their model says that your application is the container. Now, this is different from the JavaEE world. Normally, we think of our application running inside of a container. The DropWizard guys have said, yeah, no, that's not really the way we're doing it most often in production. In production, rather than the old 2000 way of one servlet container holding lots of different applications, we're moving into this more microized world, right, where we're trying to streamline things down to be smaller. We're going to put them into Docker containers, or we're going to run one application per server, or one application per blade, or one application per virtual machine, etc. So the app is the container. Those two terms are effectively synonymous as far as DropWizard is concerned. So here I have a very simple application, right? And you'll notice that it extends application templatized around my configuration class. This is so that the configuration information is available to me inside here. Notice the main. I just go ahead and run, passing the arguments into the application object. Notice the initialize method here. This is basically just where you could do some sort of startup code. In this case, we don't have anything to do. Now, DropWizard believes very strongly in this notion of resource and representation. And remember, from Fielding's thesis, those two things are different. I can have a resource, right? tedneward.com/person/ted. That's the resource, but the representation may change depending upon what the user agent is asking for. So in one case, I may be looking for a PDF representation of that resource. In another case, I may be looking for an HTML representation of that resource. In yet another case, I may be looking for a pure text or a JSON representation of that resource. So representation and resource are two different things, and DropWizard tries to honor that. So we create here a whoops, that's not Hello World application. This is the saying resource. This is basically what I'm sending back, right? This is what I'm trying to hand back. And you can see basically it's just a POJO, right? There's really not a whole lot here beyond that. You can see we're making use of Hibernate Validator in order to make sure that the maximum length of the content string is 3 characters. So, you know, if your name is longer than Ted, screw you, right? I don't know why, but just why not, right? And then you create the actual resource. So in this particular case, we create something that is effectively RESTful by virtue of the fact that we can see that the path will be hello world. It will produce application JSON. You can see the use of template and default name, right? This is basically JAX-RS in many respects. Then we register that resource. We take the application object. It has a Jersey component on it. It receives an environment object. Jersey, they actually embed the Jersey JAX-RS server as a part of DropWizard. So now you simply need to tell Jersey, hey, this resource is something that I want to make use of. I want to expose. Then, again, just as part of the extreme opinionation, if that's a word, if not, it is, I just made it up. DropWizard will require you to build what they call health checks. These are classes that are designed to monitor your application. They're designed to specifically ping your code to make sure that everything still works. So in a more traditional application, the health check would, for example, execute a quick SQL query, right? You know, select count from 1 against the database connection to make sure the database is still up. Or it might touch something on the file system if the file system is something that you need to keep an eye on, particularly if it's a distributed NAS or something similar. Or you might ping a remote server if you need to work against that remote server as a part of what this application does. As a matter of fact, DropWizard will get very grumpy with you if you do not have a health check. They will spew this really ugly message in the console saying, you have no health checks configured. You are a bad programmer. No pizza. Okay? So we can create a very simple health check here that in this particular case, all I'm doing is checking to see if template formatting works. So as long as string.format doesn't break, this health check passes. Yeah, well, if string format breaks, we have much bigger problems, right? But this is actually, again, this is kind of unique to DropWizard. I haven't seen this, particularly this level of opinionation, where they say you must have at least one per application so that we can ping your app periodically to make sure it's still healthy. It's kind of cool. It's a little bit overkill if you're just building a prototype proof of concept, but if you're actually going to take something to production, this is useful, and it's nice that they have that infrastructure already baked in. Lastly, you can create the fat jar, basically add a couple of transformers to the Maven file to take all the different jar files, strip out a couple of bits, right? All the meta-inf stuff, that needs to be excluded, and then bundle it all up into one jar file. And again, this is just straight Maven 101 kind of thing. And then when you run it, right? Again, notice I'm just executing the jar file directly. I'm going to be executing the main inside of the application class. There's no other structure here. Internally, DropWizard uses Jetty as its web server, okay? So again, this isn't something that typically you're going to bundle and put into a web server. Your application is the web server. And so this works very well for various cloud platforms that expect a main like Heroku. And then to run it, boom, there you go, you get some JSON back. And notice, by the way, that I never wrote any JSON code. I just used the default JSON property annotations to describe which things wanted to be conveyed, transformed into JSON and back again. Again, that's just the standard Java, I think it's the Jackson libraries for doing JSON serialization and deserialization. Now, the other thing that's useful is that all of that code that I wrote, you'll notice there was, aside from the health check, there was nothing really about administration. DropWizard has all of that set up, though, out of the box. The default admin port is 8081, so if you run that code as I just showed and browse to port 8081, you will, you might have to look to see what the default credentials are. I think it's admin and password, I don't remember offhand. But it will give you an admin UI showing you metrics around the application. It will let you ping the app to make sure that it's still running. You'll just get a straight pong back, which is useful for automated things to make sure that the app is still running. It'll give you the standard JVM thread dump that we normally see when you do a signal 3 to the console. You get the full thread dump or control break, I think it is. You get the complete thread dump that you get out of the standard Java infrastructure. They'll display that in a web page for you, very useful for detecting deadlocks. And lastly, they'll show you the health checks that they are running, including some of their own, displayed as JSON, which is really, really useful for doing some form of automated monitoring of your application to make sure it's still running and it's still healthy. Okay? A couple other little tidbits. DropWizard also includes HTTP client libraries, because they take the perspective that if you're building an HTTP web API, chances are better than even that you're also going to be calling other HTTP APIs. And so therefore, let's give you HTTP clients that make it easier to make those calls out of this server, as well as doing whatever it is you're doing inside the server. They don't use any particular Java ORM. They shipped with a library called JDBI, which I had never heard of before until I started exploring DropWizard. I'm still not sure how I think about that. But Liquibase as a database migration tool is extremely interesting. If you haven't spent any time with Liquibase, I strongly suggest you do so. It's available as a standalone project. You don't have to use DropWizard to use it. But if you've ever had to suffer through relational database migrations, it's definitely not a bad tool. Then they've also got, as part of that admin UI, the ability to execute tests against your code just as black box tests from the HTTP layer on back. So that's particularly useful. The last one, RestX. This one is also interesting in that it takes DropWizard as a core and then builds out on it even further. Part of what they're doing is they're trying to create a shell, if you will, a REPL, right, read, evaluate, print loop around building some of these web endpoints. So they will let you write, for example, straight up Cucumber style specifications for being able to execute tests. They'll give you a shell. It supports MongoDB out of the box. Interactive REST API docs. They basically built a Swagger-like UI for all of your HTTP endpoints to make it much easier to interact with from a human perspective. So it's almost self-descriptive endpoints, which is useful because you can just, somebody comes in, wants to interact with your server. Here's the URL, go browse for yourself, leave me alone. I don't have to write documentation. Yay. Okay? And again, they've got an admin console monitoring interactive looking at the beans that are present inside a memory. Getting started with RestX, you can download it, or this is also becoming more popular. I have a shell script up on my website. Just download it and execute it directly, because there's no way that could go wrong. It requires some trust on the part of the developer that those guys aren't doing something malicious to your machine. Once you've got it, though, start the RestX shell, and you'll see something that looks like this. Okay? Welcome to RestX shell. The current version is 0.34. And one of the first things they will have you do is do a shell install. They're going to have you pull down the latest version of the plugins that RestX uses to do its thing. Okay? So these are your first steps. Obviously, you must be connected to the internet for all of this to work. Same thing as with any sort of Maven-based environment. Once you've bootstrapped the shell, app new will create your application, okay? And they will present you with about, I think it's about 8 or 9 questions. What do you want to call the app? What's your package name? What's your group ID, artifact ID? What do you want to call the version? Some of them are directly Maven related. Some of them are directly RestX related. One of the things they will ask you is, what do you want to use as the admin password for the admin functionality? Don't lose that. Okay? Once you've done that, one of the things they will ask you also is whether they want to generate the default hello scaffolding. They will actually generate a hello world for you as a part of this application. Say yes, because that gets us to the end of what I wanted to do, is to show you that. Once you've done that, though, and you start running the application, they've set up a whole slew of different endpoints to be able to interact with the application. And this is before you had to write any code whatsoever. Now, again, right, what they're doing is they're generating some code for you. They're scaffolding some things out. So obviously you want to get to some of that code. But part of the reason you look at RestX is because they're trying to get to more of an interactive style of development. They will do some, in the development environment, they will do some on-the-fly hot recompilation of your Java sources so that you don't have to compile and then package and then run. They're trying to be more interactive so that you have faster turnaround time. And then they strongly suggest you turn off that hot recompilation when you take this thing to production. Okay? It generated a number of different scripts, of Maven POM and Ivy modules. They generated a hello resource. You can pull in all of the dependencies using deps install and then do an app run to run that class. Right? They generate 2 endpoints, a UI component or a serve component. The server component is typically what we're most interested in. Again, we're looking for building web HTTP endpoints, but the UI component is designed as a way to just quickly exercise that. And as a matter of fact, they'll give you 3 choices for the UI component. Do you want to do a plain vanilla HTML5? Do you want to do a plain vanilla HTML5 with Bootstrap? Or do you want to do something like Bootstrap plus Angular? Okay, so they'll actually scaffold out the UI as a starting point for you. You define resources using some annotations. Again, we see the use of JAX-RS style annotations, get and post, right? Oops, there we go. So, boom, there's my endpoint, hello public. Okay? Some last little tidbits. Again, it incorporates DropWizard as a core part of the environment. RestX also holds the opinion that you should not hold state on the server, period. So all of the components that you work with in RestX are intrinsically singletons. That is either a good thing or a bad thing, depending upon your particular stake in this, how much you like the idea of holding state on the server or whatnot. Whoa. Somebody's like trying to tell me to stop by just putting their hand over the screen or whatnot. They also have a really interesting error DSL. You actually stand up an enumeration with a couple of values, you put some annotations to describe the error, and they will transform that into a very, very nicely fleshed out error package, error set of components. It's a DSL. It's kind of hard to explain without looking at the code. It's definitely worth looking into, particularly if you've ever had people tell you that your error messages suck. All right. So wrapping up, 4 frameworks, varying degrees of support in terms of all the other stuff that they want to do. On the far end, we have RestX, which really is trying to be an entire development experience. You fire up the shell, you work with the shell, you modify your code in a text editor, the shell recompiles your code on the fly, etc. It's a very Node.js, interactive, dynamic language kind of experience, even though it's still Java. The other end of the spectrum, we have Spark. Spark is designed to be a very lightweight, very minimalist framework, very quick and easy. You are directly right there in the HTTP. You are dealing with those headers directly, etc., and you're not getting anything else out of the box. Vertex takes us in the direction of different languages, polyglot, right? And DropWizard is a nice mix between the lightweightness of Spark and some of the heavy, you know, the libraries and so forth, the application metrics, the health check, et cetera, that we also see in RestX without all of the shell stuff to go with it. At the end of the day, there's not one that's better than the others. They're just different. There are 4 different tools to put into your toolbox and use as appropriate. And with that, I bid adieu. See ya.